I wonder if my disk ran out of space. No, it's got a lot of space. That is a good time. Let's have a look. Okay, so I restarted that part of the stream. Did Discord cut out at any time? I know my internet is just getting better and better. I'm just so proud of it. I have the best internet ever. Was it just this example though? We could just walk through it again. So it is on the screen. Only 12.4 was missed. Let me restart this guy. Stop Discord and restart it. Okay, so maybe that is better. Let me know as I talk through 12.4. We're not in a hurry. We are in the opposite of in a hurry. We have so much time. So if I have to do stuff again and we don't fit everything in today, it's all good. The plan wasn't really to fit everything in today anyway. But I'd like to do 12.4 and 12.5 at the very least. So let me just read exercise 12.4. We have the area of a shape being 100 centimeters squared. I want to design a shape, the same shape, but the dimension should be 20% larger. Just answer everything. What's the new area? What is the scale factor? What's the percentage change? All of it. So don't look too far ahead. We'll just focus on what I already wrote down. So the old area is 100 square centimeters. The side length increased by 20%. That's what they said. I then interpret that as the scale factor being 1.2, 20% above my base. That then immediately tells me that the area factor, the factor by which the area changes, is k squared. Because this is essentially 12, I can easily calculate that as 1.44. So now I know how the area changes. I just have to calculate the new area. The new area is its factor, k squared, times the old area, which in this case is 1.44 times the old area, 100 square centimeters, and I get 144 square centimeters. So now I can interpret that area change in a variety of ways. I can say, well, the new area is 144% of the old by looking at k squared. Not looking at the new area, it was just convenient because my original was 100. So it's easy to interpret. I'm interpreting the area factor. Or I could look at the area factor and just focus on the change amount, which is up by 0.44, which means the old area increased by 44%. So as long as I understand the link between the length scale factor and the area factor, I don't want to call that scale factor as well, I'll call it just area factor, being squared, the square of the scale factor, then everything else, all the other interpretations about that is the same. But in terms of how I go from decimal to percentages. Okay. All right. Let's at least fit in 12.5. Let's drag it over. 12.5. The area of a shape is 50 square centimeters. I want to design the same shape, dimensions 25% smaller. Again, answer all the questions about area. Oh, I'm out of space. So I want to do this one at least, and then leave you to think about 12.6, which just covers all the possible combinations of things that could be missing. But it's more of a summary exercise. It's not anything new, so it's a good test for you to see where you're at. Okay, so my original area is 50 square centimeters. They say that the length, the dimensions decrease by 25%. That then tells me the scale factor, which I'll just always use a K, is 0.75. I go down from my base 1. That then tells me that the area factor, I'll call it, that's just the name I use to tell these things apart in my understanding, is K squared, which is something that I don't want to risk now. That's 0.56 something, isn't it? 0.5625. 75 times 0.7. No, 75. 0.75. Ooh, I was right. Yay. 0.5625. Now, because I'm going to use this in a future calculation, do not round this. Do not round this. Only round when I'm sort of presenting my final concluding sentence. Then you can round it. But don't use a rounded number in a future calculation. So my new area is going to be the area factor times the old area. I'll just write it out in words. So it's going to be 0.5625 times 50 square centimeters. I'm not doing that in my head. 565. Oopsie, that was not what I wanted to press. 25 times 50. 565 times 50. Yeah, okay. 28.125 squared centimeters. Now I can interpret the change in the area in a couple of ways. By saying that the new area is 56.25% of the old or original. Or I can say that the old area decreased by, now I have to show it in the chat maybe. The difference from 1 to the area factor. Difference from 1 to the area factor is 0.4375. So that means it's a decrease by 43.75%. The gap from 1 to my area factor. Because I'm talking about area, I have to use the area factor. Okay, so I want to be comfortable with a couple of things, really not that many. That it comes up over and over and over. The link between length and area changing, scale factor k versus area factor k squared, depending on which I'm talking about. Then, regardless of which I'm talking about, take that factor and interpret that in a couple of ways using percentages. All right. Now we do have another exercise, but I want you to just fill it in, fill all the missing question marks in. This covers everything, all the combinations. So for example, the first one, we're given the length scale factor. What is the percentage change that can be interpreted as? What is the corresponding area factor? What is its percentage change? And then different things are given, and you can use that to calculate all the others. Now, if this seems confusing, don't do it. We are going to do it. We're just out of time for today. But it's good to sometimes just try something on your own. Just see where you're at. It doesn't have to be 100% at all. Just to see, maybe some questions come up as I try by myself that I didn't notice before, and then we can address that. Let's just have a quick look at the schedule before we part ways for the weekend. Not in April. Don't scare me. All right, we are on Friday the 5th here. Right on track. Now, I didn't think, well, I didn't think, I didn't know how overwhelming it might be by the end of this week with all those Euclidean constructions, which, by the way, I'm still trying to upload to YouTube. Every time the upload gets stuck, and I don't know why. I am trying. Find a live video in the meantime. So I thought to build in just a little catch-up session on Monday as you try some stuff over the weekend. Maybe you have some questions. Let's just pause and address those things that may come up. So no new lecture on Monday. Q&A. Bring the Q's, I'll bring the A's, and maybe you uh, feel better about things. We will continue with that exercise, 12 point whatever it was, on Tuesday. Now, admittedly, that is all technically that is scheduled for Tuesday. So I will start with transformations. I think let's just get ahead of the game a little bit. So we will have lectures starting on Tuesday again, but we might run out of steam by the end, run out of things to do. I'd rather get things done and then have more. Then you'll also see here, just to display my brilliant memory and observation, that I copied the previous semester's calendar and modified it to this one, and Remembrance Day somehow made it through. So we are going to have our own little Remembrance Day, which is really just going to be another Q&A session. So if you see this on the following week's schedule, that's just because I copied stuff over from last year. And there it is. But we can all remember some math. I know. You can't make these things up. You really can't. So it's just another Q&A session in the build-up to quiz 3, in case you get confused. So we're going to have a lot of time to ask questions. Maybe too much time. But hey, it's done. The schedule. I can't erase the schedule. It's done. So just so you know what is coming up. Are there any questions about anything other than my competence in schedule making that you want to bring up at this stage? If you're ahead of the game, this is easy for you. Great. Enjoy the weekend. Don't worry about it. But if there's something that you need to just double check if you're on track, the weekend's a great time. Or Monday, or both. All right. Have a good weekend. Enjoy. See you later.